So I'm going to talk about the false place solution. We preferred Scantron, and this is the agenda of my talk. And first, let me introduce my members. And we are consisted of 4 people, and all are from the same company, Preferred Networks. And I am Shunta Saito, and other 3 members are all in this session. And yeah, let me move on to the main part. And in the beginning of the competition, we did some EDA to decide the direction of the experiments and found some interesting points. The first one is that we could actually find the almost same sentences as the answer options of given datasets in the body text of the Wikipedia articles. And the second finding is on injecting the text, which is just copied from the body text of the Wikipedia article as is, and into the context part of the prompt, can improve the performance of the question answering score significantly. And the third point is that even when we use LLM in a zero-shot manner to answer the question by giving the question and options as a prompt, just adding the related part of the Wikipedia articles also improve the accuracy of the zero-shot answers, even if we perform no trainings. So from these points, we concluded that we can use sentence-wise full text search on the whole Wikipedia articles to get related text that can be used as context. And we thought that it's better to focus more on the retrieval part, improving retrieval part rather than modification of the model architecture and so on, from the second point above. And the last point in the findings implies that we can use an LLM in zero-shot manner to evaluate the quality of retrieval methods. So we could quickly perform trial and errors to find better retrieval methods without time intensive training of large models. So yeah, this is the main direction of our experiments. Yes, let's move on to the method in detail. And first, for the retrieval part, we use Elasticsearch to perform full text search on the whole Wikipedia articles, and which is an open source and full text search engine, and it is enough fast and accurate to narrow down the initial candidate of the text to use to be used for the context. And first, we tokenize the questions and options in the given datasets and remove some stopwords from the tokenized results and throw them as queries and perform OR search on the Elasticsearch DB, and extract the top 10 sentences from the retrieval result and rerank them using 3 different scores. The first one is called V3 here, and this is actually about the reranking using the scores returned by the Elasticsearch itself as is, and it was maybe on BM25 scores. Sorry, and V5 means that to use edit distance between the query and retrieved result to reranking for reranking, and V7 means that we use of semantic embeddings to calculate the distances between the queries and retrieved sentences to rerank them. And regarding the model part, we found that using as many contexts as possible improved the performance of the trained model. So so we use as many contexts as possible, both in the training part and inference time. And all the experiments are basically performed by using the Jupyter V3 large model in a multiple choice problem setting. And another important point in the training models was to create a good validation dataset. And we actually extracted 2,000 data from the combination of the multiple training datasets. All come from the public datasets shared on the discussion board, and we succeeded. We luckily succeeded to create a good validation dataset, and it shows a good correlation between against to the public leaderboard, so we could trust our CV without worrying too much about the public leaderboard scores. And the 2,000 data used for the validation dataset is actually just created by randomly sampled from the training dataset without limiting anything. Any metadata is used to sample those datasets. So it also can include some articles which are not related to STEM regions. And this is the training settings, but I think there is nothing surprising here. So yeah, and we also did context ensemble in at the inference time, because we find that diversity of the context to answer the questions also can improve the performance of the model. So we combine the three different methods to create the context even for a single model inference. So we can get the three different outputs from a single model on a single question, and we can ensemble them to improve the prediction accuracy. Yes, our question part will come at the last of this session. So that's all from our team.